And welcome back to Global Education Zone. And today, in this fourth episode of our secondary school mathematics course, we'll be talking about formal geometry, triangles, and polygons. Now, in formal geometry, I will be teaching you eight fundamental theorems that are used in formal geometry, and that you will need to know in order to further your knowledge, in order to be able to address problems that you will encounter in mathematics. So let's start on the first one. The first theorem is that the sum of angles in a triangle is 180 degrees. So this I'll give you that. So in any triangle, when you add the angles, if this angle A and this angle B and this angle C, then when you add them, A plus B plus C must be equals to 180 degrees. Sum of angles in a triangle is 180 degrees. Then the next theorem we're talking about is the exterior angle of a triangle is equal to the sum of the opposite interior angles. So what that means is that, let me draw another triangle. Okay, we can still make use of this triangle. If we extend the baseline, now this exterior angle here is the angle outside the triangle. And now what we're trying to say is that this angle here will be equals to the sum of the opposite interior angles. That's the sum of A and B. That will be A plus B. That's what it means. That's the second theorem 2. So the exterior angle of a triangle is equal to the sum of the opposite interior angles. Then the third theorem says that the angle sum of an n-sided convex polygon is 2n minus 4 right angles. So what that means is that anytime you are given a polygon, and a polygon, what's a polygon? A polygon is a figure with 3 or more sides. So a number of polygons are triangles, quadrilaterals, pentagons, hexagons, and so on and so forth. So those are polygons. Now these polygons, anytime you are asked to find the sum of angles in a polygon, it is given by 2n minus 4 right angles. And what's a right angle? A right angle is 90 degrees, right? So you can see the formula as 2n minus 4 times 90. Or if you factorize 2 out of the equation, you can see it as n minus 2 times 180. So that's the formula for calculating the sum of angles in a polygon. It could be, you can see it as n minus 2 180 or 2n minus 4 90. So that is the third one. Then the fourth one for now is the sum of the exterior angles of a convex polygon is 4 right angles. So that means this fourth one says that the sum of the exterior angles of any convex polygons. Now if this is any convex polygon, so a convex polygon is basically any polygon that does not have an oblique angle. So it's a polygon that does not have a reflex angle. So all the angles in that polygon will be less than 180. So in this kind of polygon, what I'm trying to say is that when you sum the exterior angles, so the exterior angles, let's call this A, exterior angle, let's call this B, exterior angles, let's call this C. So when you sum D and so on and so forth, when you sum it, so A plus B plus C plus D and so on and so forth will give you nothing less than 360. Nothing more than, nothing less than 360. So it's equals to 360. What that means is the sum of the exterior angles. These angles are outside the convex polygon, and the convex polygon is one that does not have any angle greater than 180 or equals to 180. So anytime you have such a polygon, the sum of the exterior angles will be 180. Now let's talk about congruency. Now congruency is the condition whereby a triangle is equal in area to another triangle. Now, and when two triangles are congruent, it also means that they are similar. So they have to be similar first before they will be congruent. Now there are 3 conditions, or rather there are 4 conditions for a triangle to be congruent to another triangle. So the first one is that you must have you must have 2 sides, S, an included angle, and another side. So what that means that when you have a side and including angle on another side and these three are equal, that means that's the first condition for congruency. The next condition for congruency is that you can have the three sides given, and when their three sides are equal, that's another condition for congruency. Then the third one is that you can have two angles and a given side. So that has two forms. You can have angle 1, angle 2, and given side, or you can have angle 1, side, and angle. So you can have it as AAS or ASA. So that's the third. Then the last condition for congruency is you can have a right angle, you can have the hypotenuse, and any given side. So when you have a right angle, a hypotenuse, and a given side equals to each other, you can conclude that the two triangles you are considering will be congruent to one another. So moving on, without wasting much time, let's move on to the remaining theorems we'll cover in this video. And the fifth one we'll cover is that the base angles of an isosceles triangle the base angles are equal. That's the fifth theorem we'll cover. Then the next theorem we'll cover is that the opposite sides and opposite angles of a parallelogram are equal. That's the sixth theorem. So that is the sixth theorem we'll cover. Then the next theorem we'll cover is that whenever you have a parallelogram, the diagonals of that parallelogram will bisect one another. So that is the seventh theorem. Diagonals of a parallelogram bisect one another. Then the last theorem is that whenever you have whenever three or more parallel lines cut off equal intercepts on a transversal, then those three or more parallel lines will cut off equal intercepts on any other transversal. So three or more parallel lines that cut off equal intercept on one transversal will cut off equal intercept on any other transversal. And basically, parallel lines are lines that never meet. So in case you have forgotten, so those lines are never meet and they always go in the same direction. So those are the 8 theorems we'll be covering in this book. In this video. And for more information, you can also check more videos in this channel. Thank you for watching.